it looks like we have a very distinguished crowd. How many of you remember when you fell in love with GPS? Most of you are old enough to remember, right? Do you remember when you fell in love with GPS? Yeah, okay, life before GPS. I fell in love with GPS when I was flying Coast Guard helicopters in the late 1980s. And one day, once GPS got installed, I went from spending most of my time wondering where I was and where the fuel was and whether or not I'd run out of fuel, and not spending a whole lot of time looking in the water for the people I was supposed to rescue, to spending most of my time looking for people in the water that I was supposed to rescue. So I can tell you, I know hundreds of individuals who are alive now today because of GPS, and just multiply that by the billions of experiences out there in the world, and you get some idea as to the benefit. But, GPS was invented as a weapon system. Dr. Parkinson's goal was to put 5 bombs in the same hole. And even though the United States government has encouraged folks to use it for any number of things over the last 50 years, and it's been incorporated to every technology and application you could possibly think of, it's still today a weapon system. If you look at Israel and you look at the Ukraine, it is being used aggressively to attack others, and it's being abused to deny others the ability to attack the defenders. So it is very much a weapon system. But at the same time, because of its very wide adoption, a member of our National Security Council in the United States has said that GPS is a single point of failure for America. It's a wonderfully precise, wonderfully useful system, but at the same time, its structure is such that it's an incredibly weak signal, so it's very easy to deny. And because we wanted everybody to adopt it over the last 50 years, we published the signal specification, and that's how it became incredibly easy for smart engineers and technologists like yourself to incorporate it into so many applications and technologies. But because the signal specification is out there, it's also very easy to imitate. And so all of our GPS, all of our position and navigation timing services, primarily provided by GPS, are very much at risk. And everything that depends on them are very much at risk. So we're going to talk about how that works here in Canada today with our distinguished panel who has volunteered to come in. And so I will, now that I've been introduced, I will ask each of them in turn to say 30 seconds about themselves, where they work, and how they came to love GPS before we get into the questions. So, Adrian, off to you.
Test 1, 2. Okay, thank you. I've been fiddling around with GPS since about 1990, and have a particular interest in space weather and its effects on GPS services, so we'll talk a little bit about that. I work with Hexagon Autonomy and Positioning, and we, amongst other things like building receivers, we have some of the technology to deal with spoofing and attacks and to mitigate the effects of space weather.
Morning, everyone. Sunil Bisnath from York University, and I guess Dana, it was about 1995, and I had a geodesy professor come to me and he said, "Would you like to work on this thing called GPS that I've never heard of?" And so, 30 plus years later, we've been able to see so much in terms of development, where it was just a very commercial service. We looked at high performance positioning. I don't know if any of you in the room remember having to get up at 3 o'clock in the morning to have enough satellites to actually do PNT. So it's been a long time, and it's just amazing. We're busier than we've ever been on the research side.
I'll use this one. Good morning, everyone. My name is Jennifer Wharram. I'm a career federal public servant, not an expert in GPS. I came into this world about 7 years ago when a former boss said, "Hey, Jennifer, we've got a really cool thing going in the government of Canada. Could you come and help us move it forward?" So that's my story. We have a collaborative forum of government departments who are very interested in or are users of GPS. So we work together to try to make sure that we're not duplicating efforts, but also looking at complementary and PNT as well as our risks associated with it.
Let's see if I'm in the hot spot here on the, no feedback, good. Andrew Hansen with the U.S. Department of Transportation. I'm not going to follow your lead, Dana, and start counting years. But it was the 80s when I got started. And what's interesting to me right now in this moment is the ability to talk to each of you, because I had the good fortune of being mentored by some of those pillars that we hear in voices, some of whom are gone now, and it's hard for me to think about that. But what's heartening is to see so many faces of people that care about making this system that we have for PNT resilient. So things like Dana's story about really saving lives or making it possible for people to do things that they wouldn't otherwise be able to do real. And I've had the chance to talk to a couple of students and burgeoning professors this morning, and it really gives me a lot of energy. And it's very heartening, and those things that Pat likes to cheer for can happen. And it's a pleasure to be here. It's my first time at Humber, and I'm looking forward to sharing with all of you what I might have. Take it as a grain of salt, and then ask for more and feedback the kinds of things that can make the next step as much of a revolution that GPS did 50 years ago now with things that are the next step. So I look forward to the conversation, Dan.
Great, thank you. So we have some pre-scripted questions. We will also, so they are very smart people, but we have given them some of the questions in advance, so just so you know. But we also want to provide time for your questions as well. So we'll set the stage with some pre-scripted questions and some panelist comments, and then we will open the floor. Hopefully we'll have enough time to answer some of your questions, and then, of course, everyone will be around for the rest of the day. So let's start off with our representative from government. Jennifer, so tell us, what are some of the ways that Canadians and their infrastructure use and are dependent upon GPS and other global navigation satellite systems?
That's great, thanks. So we have done a number of studies amongst our federal family to try to understand our dependence on, because with dependence comes risks. You can't look for solutions unless you know your dependence and the risk associated with it. So Pat did a great job explaining kind of the critical infrastructure segments. In Canada, we have 10 critical infrastructure sectors. So we do look at those that impact our safety or economic well-being for the country. But there's also some key economic sectors as well that are heavy users. And so we've folded some of those in as well. So if you look at it from a user perspective, it's no big surprise. From a positioning side, we've got a lot of roads and a lot of construction in Canada with our seasons. So surveying and construction industries are very heavy users. But also from the federal side, we have our Canadian hydrographic services for tide gauge measurements. We've got 3 coastlines that we have a Canadian Coast Guard that needs to monitor. And I'm just talking about civilian uses here, not the defense. And then if you look at the navigation, of course, it's all forms of transportation. Drones are heavily used in a lot of different sectors of our economy for monitoring infrastructure, towers, places that aren't necessarily easily to get to. And then we also have, from a navigation side, machine guidance. So we have a lot of mining as well as manufacturing. And so for increased automation, you have a lot of GPS or PNT use. And then the timing uses are pretty clear from networks and anything that needs a timestamp. So traceability, precision, and synchronization are key factors there.
And has precision agriculture taken hold in Canada?
It has to a certain degree. There are other places in the world that use it maybe a little bit more heavily in some ways, but it's heavily integrated into the machinery that most of our large farms already use. So if they're buying a tractor, that already has a lot of precision ag incorporated into it.
So for some folks who might not be quite so familiar, precision agriculture clearly uses precise precisioning, and also allows, even though of course the technology costs money, it allows farmers to use much less pesticides, much less water, much less fertilizer. And so costs are much lower there, and of course the environmental impacts are much less of all that. So, good. Any other thoughts from other panelists on the infrastructure issue?
Well, I'll just pull on that thread a little bit on the precision agriculture side. We're actually seeing now the progression of a second generation in agriculture. Precision ag is pretty well established. It's very clear the benefits you can get out: reduced fuel use, more efficient resources. Dana's right on, so it has an economic strength. The question is now, can we move to a higher level of automation? Right now in precision agriculture, you typically will still have your farmer in the tractor. And I know this for sure. I'm back to Nebraska on a regular basis at my own farm. And the situation there is that in the economic strength that's happening, automation is the step that's moving forward. And this isn't unique, but I'm using agriculture as a mechanism because automation, we understand, in many other sectors is taking hold. I think that agriculture is a good place to be doing deeper research on resilience and automation that would help safety systems and other places where it's a little more difficult. You're working in a space that isn't an open field where you can gather information in a much more robust and yet safe way. So there's a progression that's happening in these next generations of sectors that have already leveraged GPS for huge benefits. And I think this moment is one of those ways to understand what is the next big step. So you're going to hear me say that over and over again, and but I'll use the precision ag as one of those opportunities.
Great, thanks. So, Adrian, GPS is vulnerable, but what are some of the ways in which it can be disrupted and made less useful or even dangerous?
I love the pre-scripted questions. It feels like we're on one of those TV shows,
Right.
Gee, Bob, is it really that good?
Yeah. Makes you seem even that much more smarter.
Yeah. I'm going to come back to the agriculture thing as well, actually. So there's 4 ways that I can think of. Some of them have been mentioned here that the GNSS can have trouble. One, of course, is system failures, which was brought up, and they're infrequent, but they're significant when they happen. And we've had, as well as the ones mentioned today, we've had, or the one mentioned today, we had a fairly major outage at GLONASS a while back, the Russian system, and a significant enough outage on the Galileo system, the European one. So that's one way that it can happen. Another one, of course, is deliberate interference, jamming, spoofing, that sort of thing. One of my nerdy hobbies is I fly weather balloons around the world, and I put a GPS tracker on that, and I've had they go dark right now over the Ukraine, obviously, and you just don't know where your balloon is till it floats out of that area. But so there's a lot of GNSS denial that's intentional, and bad actors, that sort of thing. The other 2, I'm going to get to space weather, but there was one I was going to mention. Let me just remind myself here. Oh yes, the governments control the various systems. They're typically nationally owned and operated services, and they may elect in certain scenarios to degrade the service. We all maybe remember selective availability, but that is something that could happen. And we're our phones and that are relying on foreign services as well as our domestic ones. The last one is space weather. This is a hobby of mine and professional interest. And space weather is the effects of solar activity. And that goes on a number of cycles, but the biggest one is the 11-year cycle. And we're on what they call cycle 25 now, since they started measuring it. We had 25 of those cycles, and we are going to hit the peak of that activity they're now forecasting between January and March of next year. What that means is you start seeing a lot of degradation in service, inaccuracies that happen. For example, the agriculture example, we're quite involved in precision ag. Planting of sugarcane, when you do that, you plant your seeds for 7 years, and you do what they call an as-planted record using the GPS system when you plant your seeds. That record is then used for the next 7 years for fertilizing, harvesting, and so on. And so if you've got a wandering line, you're going to be inefficient for the next 7 years. So you've got to have that right. And we need it to be sort of 2.5 centimeters, 3 centimeters accuracy. We also have a company we work with in Africa that flies drones that delivers blood from where the blood's donated to the hospitals. And it's really cool, a company called Zipline. And these drones crash if there's they can't fly right now between 7 p.m. and midnight because the solar activity is so high right now, and we found ways to fix that, but it's a challenge that we didn't have in the last solar cycle because we weren't using GNSS to this extent, and we weren't using it so critically as we are now. So we're kind of in the first time we're dealing with a major solar storm level and relying on it so much. Just one last comment on relying on it. There was mention about the power grid. For us in Canada, you may remember 1989, we had another solar peak, and it caused the power grid to fail in Quebec. For 9 hours, there was no power for 6 million people. So critical infrastructure could be affected by something as simple as just a natural phenomenon, space weather.
So Adrian, I was downtown Toronto yesterday, and my GPS was bouncing all around. What are some possible reasons for that?
It's probably, if you're downtown, multipath. It's the signals bouncing off the buildings, and there are ways to address that. I just made it here in time today because I took 2 attempts with Uber because both guys were complaining that their navigation was off and they were on the wrong side of the road and they had to go around the block and this sort of thing. And this is something I've been talking with those companies about. But yeah, the solar weather can be definitely one of the things that can, if there's a storm, you can see your system bouncing around. A lot of us don't realize how inaccurate our smartphones are because we see the dot on the map because even though it's off by 7 meters, the software says, well, you're not in the middle of a building, you're on the road, you're navigating, right? So it snaps it to grid. So you think it's doing a lot better than it is. If you have the raw data, you see what's really happening.
Okay, so for the panel generally, Adrian mentioned malicious interference. Why would somebody in Canada intentionally interfere with GPS to deny or to spoof it and give bad information?
Is this that stereotype that Canadians are always nice? Is that what it is, Dana?
Yeah, why would they do that? How rude.
Lots of reasons. I think one of the obvious ones in transport is that the drivers don't necessarily want their managers to know where they are. So you can go on the market, you can go on Amazon, buy these devices. I'm sure Jennifer will say, because I said is in charge of this, all these things are illegal, but that doesn't stop people from doing it. Everything to things like car theft rings. And these are all now in cities like Toronto, it's organized crime, right? These aren't just kids stealing a car. This is organized, and we find the cars in countries like Ghana. These great reports are done. The one other thing I'd ask about, separate from malicious intent, is the 1 hour the one other denial of service that we haven't talked about because it's obvious. It was never designed to work indoors, right? So we always assume that you have a bright open sky. So when you were downtown Toronto, too many buildings, it's just the signal blockage itself. So that's the number one, in a way, denial of service that we have, is that we don't have open sky if we don't have open sky. And we tend to leave that one out.
Oh, that's a really good point. And we think about malicious interference, but the Europeans did a big sampling for a couple of years, and they found out that GNSS signals were being 90% of the time when they were being disrupted, it was some electronic equipment that was leaking radio frequency, and only about 10% of the time was it somebody trying to hide where they were and that sort of thing. So yeah, very, very weak signal, necessarily weak, so it doesn't compete with itself and so forth. It comes from 20,000 miles in space, powered by solar panels, but all kinds of issues with that. So yeah, so Andrew, what can folks do to protect themselves against GPS disruption and manipulation?
It's an excellent question and very pertinent to today. The first thing, and it's going to sound trite, but it's real, and we're finding this out based on things like 13905 and other policy. But it's first of all to know you're using GPS. And that, again, it sounds like an obvious question, but when you have an application that's a blue dot on your device or an invisible piece of electronics in your vehicle, it is not clear when you're using GPS. So the first thing in saying, hey, I've got to find a way to make more resilient that thing that I'm using is to know you're using it. The next thing is to understand that diversity is your friend. GPS is in some ways a victim of its own success. That open standard that allowed the entire world to innovate on GPS drove things to chip scale, $1, $2 kind of thing that could give you nanoseconds level of precision in time, could give you positioning under the right application and in the right space, 1 meter, 2 meters of accuracy. Those are huge economic levers. And often in economics, we're optimistic. We're going to go use that lever. And it's not considered about where in those off nominal or situations where you might not have that level of performance, what do you do? We have taken the step in the US, and we're hoping to be leaders around the world, and it's very good to be in partnership with Canada in bilaterals, about actually going through an evaluation process of how you're depending on GPS. If you are a standards geek, which I am, NIST, our National Institute of Standards, was asked out of that executive order to give us good guidance on how to evaluate what you're depending on in your PNT sources and where they might have vulnerabilities. That's a lot of work, but we as government have the role of setting the stage for that, going out and showing how we can do it, because we built the system in the first place. Let's show how to make it more resilient. So NISTR 8323, you want to take it down or get a link? That's an interesting exercise because it sets the stage for how we're going to be more resilient and what can you do if you have a GPS disruption. I could talk all day about the technologies that are there, but I'll reference back good guidance that the U.S. government received out of the PNT Advisory Board. Dana and Pat mentioned it already, and that is to start categorizing what should you do. Protect, toughen, and augment is a set of principles that advisory board told the government very explicitly need to start thinking in these ways, not just opportunistically about economic levers. So PTA has a whole host of protect, meaning it's an RF system. Spectrum allocation is a big deal, and it's long, slow, and hard. All the advances we made, we need to protect those. Toughen, it's a weak signal. There's a lot of smart people, better antennas, better processing, better understanding of the elements that you're depending on, even though they got refined to a dollar chip in ASIC. What else can you do? There are new things in processing to toughen your use of PNT. And the last is to augment, and I want to close up my responses in that augment, I think, is exactly why many of you are here. ATSC3, I'm not sure you understand what a gem you have in that standard. Standards work is hard. Do you have a very good standard in ATSC30? And taking technology solutions through standards to augment gives you a lot of resilience when there's a disruption to something else you're depending on for the same kind of function.
So I like that you started out with the Alcoholic Anonymous first step of first you need to recognize you have a problem, right? That's the first of the 12 steps, yeah. So that's an excellent point. I wouldn't have thought of that, but yeah, certainly there are both hardware and software solutions and for individual receivers, and then alternatives. So, Jennifer.
Yeah, I think those are all wonderful points. I always think you have to start with your use. One of the things we discovered when we did a lot of interviews of our critical infrastructure sector leads in 2019 was not everyone was aware of their threat environment. So yeah, they may have understood that they have a use, but they weren't really aware of all the activities that could could impact them. And then from that, they also didn't really have a good sense. Some did more so than others, but what level of risk were they willing to take with their vulnerability or their dependence? So from use to threat environment to understanding your risk, and then you can start looking at how do you want to mitigate it? What kind of solutions do you want to look at to lower your level of risk? And then the final part was most of them had no way of detecting if something went wrong. Like, so if something goes wrong, how do you know? Are you being spoofed? Are you being jammed? Are you, is there just a system anomaly? So I think marrying all those ideas together is what's going to be needed from a diversity perspective.
Other thoughts?
Well, not to get too far into the weeds, because there are other questions, but there are other technologies out there. Sorry, folks, I know we're here to talk about one thing today, but and they continue to get developed. We have inertial and other sensors that we've been augmenting GNSS with for decades, and they keep improving in terms of quality and cost. And a number of other satellite-based alternatives to GNSS. We're into the world of quantum, we're into the world of AI, and these technologies aren't going to help make us, hopefully better stock picks, but also will help us in PNT as well. So there are other sensors, and the way I've looked at this, many of us for a long time, is that it's marrying sensors, right? It's loosely or tightly coupling sensors that will help build the resilience, but it raises lots of questions, like how do you define something like integrity if you have 3 or 4 sensors? And we have great platforms like our cell phones that have literally half a dozen navigation sensors on them.
Just adding to that, we talked about indoor positioning. There's a lot of people wondering, well, my phone does work when I'm indoors, so how is that working if I'm not getting GPS? You're probably using Wi-Fi positioning. There's a database that Google runs and Apple runs that has as many Wi-Fi access point IDs as they can crowdsource and put in their database, and that's reasonably effective, but again, it's a dependency. But on the GNSS side, one of the developments that is happening is the proposal from several companies to launch low Earth orbit satellites to instead of having these medium Earth orbit satellites we have now. The benefit there, we talked about the weakness of the signals, is they're going to have much stronger signals. Now, it's not going to work everywhere indoors, but it'll certainly improve the cases where through the windows here and such, you'd be able to get some useful signals. And that's exciting stuff that we're going to see happening in the next sort of 2027 onwards. We'll start seeing some of those deployments.
Right. Very good, thanks. So it's an interesting problem because, as you say, there are solutions, but it may well be that we're still at step 1, acknowledging the problem, and to get to step 12, we have to go through the entire process of acknowledging, deciding we're going to do something about it, and actually making the change to get where we need to be, so that life is different. Yeah, but it's not just a technology problem, but very much a social and political and policy problem. Which leads me to our last question, and this is about this question is, what can governments do to protect themselves and the citizens? And because we are in a democracy, we're not going to ask government about that. We're going to ask one of the citizens. So, Sunil, why don't you lead off with that?
Sure. The idea here is that, it's to get the government off the hook and have an academic respond, because I can't get in trouble. I can't get in trouble for saying all kinds of crazy things. Pat talked about, and Andrew about the problem, the first, and Jennifer has as well, victim of its own success. So people will say, especially in industry, it works fine. Why do I need to do anything? Right? That's one of the big issues. So what do? Wait for a big outage, something disastrous, that we then have, the news around the world saying, oh my God, we've got to do something about this. That's one way, but that's not a very good way. But it's the awareness piece. Yeah. It's really the awareness piece we see is a big part of this. People don't know if they're even using GNSS, or they don't know how they're using it. They don't know how it impacts the chain in their solutions. And it all works fine. So why should I spend any money or lift a finger to do anything about it? And that's a big thing. In the Canadian context, um, uh, policy. Good policy is so important. Not just good standards, but having good policy. Yeah, Andrew's shaking his head after decades and decades of fighting this. So we've advocated for what best practices that we've seen around the world. The Australians have been terrific at communicating with their government, getting funding for correction services and ground infrastructure because they've had a plan. They had a strategy and a plan, and we've advocated for a PNT strategy for Canada as a whole, and helping Jennifer. And Jennifer's doing everything she can to get this, but it is a bit of herding cats, especially if people aren't aware that there's a problem or everything's so great that they don't think they need to do anything. But it's not an impossible problem, right? People have solved this. We've also advocated for something like that exists in the States with the PNT Advisory Board. Technical folks separate from the government, but that are tied in at the highest levels, saying, look, you really need to do this. And then people at the highest levels are listening. So we try, but Jennifer and her team and others, they having that sort of separate but high level connection is very important. So governance, policy, awareness for the public. There are technological solutions, but they would never actually get implemented if we don't have that awareness of the problem, the policy in place, the governance in place, strategies that are then, what is it? You don't want a war with a strategy, you want a war with a plan. So we need the strategies, but then we need the plan. And there are great examples from the U.S., Australia, the U.K. with some of their resiliency plans. So there are really good practices that we can use here and everywhere else.
I'm aware of threats that we may create on our own, which I'd like to get some your feedback on, particularly Andrew, relating to creating RF interference. I'm thinking of the light squared, which got all the way to approval and almost implementation. And I know that was a big part of I'm a pilot, so that was a big part of our push. So I wonder if you could speak on that.
It's a good one, and it's a hard one. As a member of the team that went through that exercise in the federal government in the U.S., I will not say that was a particularly good outcome. That's not just my position, but what the U.S. government federal executive branch put forward in their recommendations. But what it draws out is that compatibility, when large systems are being put together, is absolutely critical. You cannot worry about compatibility at the end. So I don't want to just pour salt on the legato thing at the moment, except to say, from our agency, we apologize that has made a very difficult situation around the world, because that spectrum question that got answered in a certain way within the U.S. federal process is now being writ large across the country, across the world. We understand that often we set precedents. So that is a very difficult one. What I will say on the hopeful side is that it's a lesson learned, again, about compatibility. And I'll foot stomp that as new technologies are coming along, I like to say we need more than the sum of the parts. But part of that statement is ensuring that not only are we getting something better, more than the sum of the parts, that we're not introducing an unintended consequence. And those might even be obvious, but we have to work very hard that those unintended consequences are understood and pushed back.
My name is Anurag. I'm a postdoctoral at York University. And my question is that first question is that since we are talking about the timing and the positioning and navigation side, does the panel think that there should be two different systems when it comes to time and position navigation? Because with the GPS, the advantage was that we got the time because it was a timing based system with the position. But does the panel think that it is better to bifurcate the two into position and then navigation as a backup? The second question is that with technologies like ASTC and other technologies, how are we gonna do in the positioning domain? Like we already had LoRaN and enhanced DME and enhanced LoRaN, which were actually seen as an alternative PNT, and we already had that system. So how this system can go into like a meter or a 2 meter level, or are we happy with the 10 meter when it comes to positioning?
Well, I think this comes down to what are the user requirements. So if a user has a distinct need for precise traceable time, then they're going to look for solutions that are going to meet that specific need. If you're looking to invest in something that meets the most user requirements, then maybe you need a solution that does a little bit of everything. And then I think the key is it's a system of systems. It's a diversity. So it's not, there's never going to be one single solution that's going to meet everybody's needs like GPS. So we're going to have to layer it. And I think it's looking at who do you layer it with and can you get the most bang for your buck?
All up or back and going to academic roots, the advice, I don't get to say what everybody does, although I try and weigh in. To the specific question, I highly recommend not separating things. As a conventional wisdom that has come out of developments for hundreds of years, use all the information you have, but use it wisely. And the point there is that often if you separate a function by itself, it is a much easier target. So if you are going to use something that has benefit for both positioning and timing, you're better off in the handset or wherever you're utilizing that function to include all the information you have. And you can make trades in that space, to exactly Jennifer's point. The classic one, and I don't mean to have a soliloquy here, but is RAIM. If you're familiar with GPS, it was baked in from the beginning where you would use redundancy in the information you have, in this case multiple satellites, more than you needed to generate a position solution. And in fact, you can make a trade in that algorithm to give up accuracy to gain integrity. I have 8 satellites in view. I can start throwing some of those away, not because I want less accuracy, but it can tell me whether I should trust the rest of them. That principle applies in any complementary information system.
Thank you. Good morning, all. Just a question. Is there any policy to develop a data platform gathering all the areas and the correspondent sectors that could be affected by the loss of GPS signal, especially due of interference? The information that we have, the time of the interference, the duration, how long it will last, and the rate of the intensity of the interference. Thank you.
So you're asking, is there a program to have a detection and interference monitoring program system?
Correct. Yeah, something like that. Yeah.
Can I get it from an academic perspective? We would love to do that. The thing is, it's illegal in this country and most countries to do that, right? No, I know, but the thing is, how would we have sort of the catalog, right, or the reference to say, for this kind of signal, or this signal strength, this range, this bandwidth, what would the effect be on GPS L1, L2, L5? We can't do that. We can do that in simulation. We can propose it in theory, but we're not allowed doing open air tests unless in Canada, unless you get a license, and usually that's just the military that can get those types of licenses. So one of the things that we've been advocating for from the academic point of view, and I know industry is looking for this too, is to have these types of controlled open air tests so we could develop that kind of database. Because right now it can only legally only be done in theory or in simulation. Right. So it's yeah, there are lots of detectors out there for interference, etc. But we're not allowed having a source, right? So we can't transmit an actual source.
I mean,
So we can only just find stuff, and it's kind of like the tree falls in the forest. Does anybody hear? Only if you have a detector that's in a certain place. Canada and the U.S. are very, very big places. Will you actually? What are the odds of picking up a detection signal? That doesn't mean that there's a load of interference. There's interference all over the place, but your detector has to actually be on in that location at that time to detect it. So that's why we would need sort of an evaluation process, and we'd love to do that.
but that's not to say, and I don't think you're saying this, that we have no hope.
No, it's not that no
right,
hope, but to have sort of a database and a complete
database,
reference.
Yeah.
We'd love to do that.
I mean, there are known approaches to interference that are well understood. I mean, I'll give the most simple one is that satellite signals should come from space. So if you see a signal coming horizontally at you across the ground, that's probably interference. So you can have an antenna design that looks for those and ignores them or nulls them out. So there are certain techniques to deal with anti-jam and anti-spoofing, but there's no database of certainly nothing you can predict, because by nature they're trying to do it in an unpredictable way.
I think from the federal government, or at least from the PNT office perspective, we're very interested in interference detection from a GNSS perspective. Our spectrum colleagues already look at it from a holistic perspective of all radio frequencies, but we're predominantly interested in the PNT GNSS side. So we have done a preliminary study on what could that look like for Canada. The next step will be to evaluate those recommendations and seek funding to be able to do any kind of pilot. And that includes looking at the regulatory authorities to be able to create that database of what would those signals be. So, looking at multiple sources of data that we could compile together to do some kind of detection and understand what the users want from an alerting perspective as well. So very, very, very early days, but it's still on our radar.
One last question.
Thank you. When I look back 50 years, and I can, I think one of the big differences between when that's GPS started was that our terrestrial networks, or our networks, communication networks globally, are massive and incredibly reliant on timing. Is part of the solution for this to say, let's turn the dependence on GPS upside down? So now the networks, which are fiber-based, which we know where the data centers are incredibly precisely, there is wireless everywhere, cellular, Wi-Fi, but even low Earth satellites. Can we use those as the backup when they detect a problem and they switch over to a land-based? The same cesium clocks can be on the ground as in the air. Is that part of the solution?
100%. And the only thing I'll offer right back is I'll preach now. The word backup is verboten in my office. It is complementary. It goes back to the information question. We do not want to fall back to something else. What we want now, and in fact what is in that action plan, and what I'm charged with for my political leadership, is putting together systems that are more than the sum of the parts, not what do we do when we lose that one or this one. It's complementary is the new coin of the realm. And the situation is that opens up not just in technical solutions, but in economic drivers, in the application areas, an increase in the intellectual understanding and, in fact, intellectual property from individual solutions to use of services. That's a paradigm shift right now for the United States government. We're used to building very large programs. I don't even want to try and quote the number of billions of dollars it took to put GPS satellites and continue to put GPS satellites in the sky. But if we treat GPS as a standalone, that we just fall back on something else when we don't have GPS, that money was largely wasted. Now, I'm saying that as an extreme statement, but you should never be in a situation where you're disciplining an oscillator by GPS, and then for some reason you drop a switch and say, I'm going to discipline it with ATSC3. That is a very bad design. That backup concept does not work well in large systems. You need to have complementary. You need those signals all coming in and making smart decisions in the new realm of whether it's AI or machine learning or just good engineering, bringing those together all the time, immediately, so that you're getting the best solution that is most robust, not go back to something that's 80%. That's the new mindset.
Thank you for your time and attention. Apologies for the schedule, Oris, but I hope you enjoyed our discussion, and we'll be here for the rest of the day to continue it. Thank you very much for